Be revisiting the normal distribution that we examined in Unit 3. In this case, we're going to be looking at it from the perspective of probabilities. So just to review, if you recall from Unit 3, normal distributions are bell-shaped. The data has to be continuous, so we're talking about height, marks, time, volume, anything like that where it can take on any values, so it has decimals, fractions, there are an infinite number of values. The mean is equal to the median and is equal to the mode. And if you remember, 68% of the data is within one standard deviation, 95.5% of the data is within two standard deviations, and 99.7% of the data is within three standard deviations. So that is all stuff that we've already learned about the normal distribution. So something new is what is called the z-score. And the z-score is the number of standard deviations a piece of data is from the mean. So for example, if the mean is 70, so if that's the mean, and the standard deviation is 6, so that's the standard deviation, then if you got 76, well that's 70 plus 6, so you've added 6 once, so the z-score is 1. If the person got an 82, well from 70 you've added 6 two times, so that person's z-score is 2. If the person got a 67, well you have subtracted half of the standard deviation, so the z-score is negative 0.5. For other values, there is a formula that you can use for the z-score, and the x is the piece of data, the x bar is the mean, and the s is the standard deviation. So a z-score, what it does is it relates what you got compared to what the mean is. So if the mean was 70%, then one standard deviation would be 76. Two standard deviations, you'd add 6 twice, you'd get 82. Three standard deviations would be 88 because you'd add 6 three times. On the negative side, if you subtract 6, you would get 64. Subtract 6 again, 58, and subtract 6 again, you'd get 52. What I want you to remember is that this bell curve here just represents what the histogram would look like if you were to have made a histogram showing these marks. It's just annoying having to make these bars every single time, so that's why we just use the curve to illustrate where the bars would be. Okay, so let's get rid of those bars because they're distracting. Okay, so there is no formula that we can use to determine the probability of a mark being, say, less than 76 or greater than 60 or equal to 74, things like that. But there is a way if we change the piece of data you're interested in into a So if you wanted to find the probability of a score being less than 76%, you would use the z-score formula to change it into a z-score of positive 1. And then the method we are going to learn is how to find the probability of being less than a z-score of 1. So this is what I was saying. The problem with a normal distribution is that it handles all sorts of values, which comes with different means and different standard deviations. So because the means and the standard deviations are always changing depending on the question, that's why we need the z-score. I know it sounds complicated, but the process isn't actually too hard. And so I've got a little mistake here. Just change this standard deviation to 20. So the process that you take to change your data into z-scores is called standardization. So we're taking a question which has normally distributed data and changing it into what we call the standard normal distribution, and all of these values get changed into z-scores. So these here are z-scores, these here are data values. So using the z-score, all of the data values get changed into z-scores. And once they're changed into z-scores, the mean now becomes 0 and the standard deviation becomes 1. So you see how this works out in an example. So in an example 1, the marks of a data management test are normally distributed with a mean of 70% and a standard deviation of 6%. Now, the graphs here are just an estimate. They're just a sketch. They're not supposed to be exact, just to help you visualize. So if Billy Bob got a 62% on his test, then what is his z-score? So we're going to write the z-score of 62 is, it's the data, which is 62, subtract the mean, which is 70, and divide it by the standard deviation, which is 6. Now you can do all of this work in your calculator, but what you have to be careful of is you don't just press 62 minus 70 divided by 6, because then it's not going to follow BEDMAS properly. So you have to do the 62 minus 70 first, which is -8, and then divide by 6. And that is approximately equal to -1.33. Your z-scores should always be rounded to 2 decimal places, and you'll see why in a minute. Now on the diagram, the middle here represents the mean, which, because we've now standardized it by finding a z-score which is equal to 0, and to estimate where a z-score of -1.33 is, it's not a huge deal, but I'll just give you a little idea. This point right here and its equal symmetrical point over here is approximately where one standard deviation is. So that's about where a z-score of 1 would be, and that's approximately where a z-score of -1 would be. And you don't really need to know this, it's just for the general idea of the sketch, but these points here are the points of inflection of the curve. So those of you that have taken advanced functions, possibly even calculus, it's almost as if between these 2 points the curve is what we call concave down, which means it's facing down. And after these points, if this curve were to actually have sort of continued almost like a parabola, this is where the curve is concave up, which is like the curve is facing upwards. So it's really not a big deal to know that. It's just a general idea for the sketch. That means that your z-score of -1.33 is going to be past that point of inflection, so about there. So we are looking for the probability of somebody's mark being less than that. So to start this off, we're going to use our typical let x equal a student's mark. So what we are looking for is the probability that the student's mark, student randomly selected, will get a mark less than Billy Bob's, which was 62. And that is approximately equal to the probability that the z-score is less than -1.33. We're using approximately because we had to round that. And this is how you find the probability of a mark using z-scores. If you flip a couple of pages over, you'll see this table here, which is called the standard normal table. This gives you the probability of being less than a particular z-score. So the way it works is these numbers here represents the ones and the tenths digit, and these numbers along the top are the hundredths. The table on the left represents the negative z-scores. The table on the right represents the positive z-scores. So our z-score was negative 1.33. So the ones digit is negative 1. The tenths digit is 3. So we're looking along this row right here. And the hundredth digit is 3. So we're going to look at this column. So we're going to go along this row, and we're going to go down this column, and then match it up, and right there, that is our probability, 0.0918. So 0.0918. So the number in the table gives you the probability of being less than a particular value. So that's what it says here. If you're trying to find the probability that your data is less than a particular number, you just get the number from the standard normal table. That is always less than. So we're going to look at some examples where it's not always less than. So to find the probability of your x being less than a particular value, you just convert it to a z-score, round to 2 decimal places, look at the standard normal table, and that gives you the probability. So the next example. The mean June midday temperature in Desertville is 36 degrees Celsius, and the standard deviation is 4.5. Assuming this data is normally distributed, so you have to be told it's normally distributed, what is the probability that a day has a temperature over 42 degrees Celsius? So start with let x equal the temperature and that's in degrees Celsius. So first thing we have to find is the z-score. So the z-score for 36, the z-score for our data is 42 is data minus the mean divided by the standard deviation. So that works out to 6 over 4.5, and that is approximately equal to 1.33. So here we have a z-score of 0, that's the mean. Your point of inflection is approximately here. So a z-score of 1.33 is approximately here. And what we are looking for is the probability of being above that number. So the probability that the temperature is greater than 42 degrees is going to be approximately equal to the probability of a z-score being greater than 1.33, and that is approximately equal to, back to our probability distribution table or standard normal table. So our ones and our tenths digit is 1.3, and our hundredths digit is 3. So when we line those up, we get 0.9082. But what we said is the number in the table gives you the probability of being less than that number. So this is 0.9082. So to figure out this probability here, what you want to remember is that the probability in total is equal to 1. So it's going to be 100% minus this 90.82%. So 1 minus 0.9082 is equal to 0.0918. So when you want to take the probability of being greater than a number, you have to take the number from the standard table and subtract it from 1. Now, because the normal distribution is symmetrical, notice that the probability of being greater than 1.33 was actually the same as being less than negative 1.33. And while I'm here, I should change that to approximately equal to. So that's how you answer a question where you are greater than. So to find the probability that your variable is greater than a number, you find the number, you change it to a z-score, round it to decimal places, find the number from the standard normal table, and subtract it from 1. The next type of example is where we're looking for the probability of being in between two values. So this is the one that people find the trickiest. The ages of the population at Mathville are normally distributed with a mean of 43 and a standard deviation of 14. What's the probability that a randomly selected person is aged between 22 and 57? So what we have to do is find the z-score of both of those. So the z-score of 22 is the data minus the mean divided by the standard deviation. So that works out to negative 21 over 14, which is negative 1.5. The z-score of 57 is the data minus the mean divided by the standard deviation, which is 14 out of 14, which is equal to 1. And I guess we also can't forget to give our let statement. Let x equal the age of the person in years. Alright, so on our diagram, there's approximately our points of inflection. So right here is our z-score of 1, and right approximately here would be our z-score of negative 1.5. Again, I'm not really marking you exactly on where those lines go. Alright, now to go to the standard normal table. So the probability of an age being less than 22 is equal to the probability that the z-score is less than negative 1.5. So to find out the probability of being less than negative 1.5, back to our standard normal table. If our z-score is negative 1.5, that means the 1th digit is negative 1, the 10th digit is 5, and the 100th digit is 0. So the probability is really just right there, 0.0668, 0.0668. So the probability of being less than a z-score of negative 1.5 is 0.0668. And next one is a z-score of 1. So the probability that your age is less than 57 is equal to the probability that the z-score is less than 1. And that would be all of this section all the way down to the end. And if your z-score is 1, the ones digit is 1, the 10th digit is 0, and the 100th digit is 0. So that is 0.8413. So that's 0.8413. So what we are interested in is what's in between these two values. So to find out what's in between these two values, if we take the 0.8413, so we just want this section here of the green, really. So what we do is we take the 0.8413 and subtract the blue section, which overlaps, 0.0668, and it leaves us with this green section here, which is in between our two z-scores. So the probability of being greater than 22 but less than 57 is the same as the probability that your z-score is greater than negative 1.5 and less than 1, and that means you're going to subtract the two values. 8413 minus 0.0668, which is 0.7745. So this would be more your application types of questions. Examples 1 and 2 would be your knowledge question. This would be your application question. So to find the probability that your variable is between two numbers, you take the probability of your variable being less than the bigger number and subtract the probability of your variable being less than your smaller number. What a lot of people do is they find the two z-scores and they subtract the z-scores. But that's not what you want to do. You want to find the two z-scores, find the two probabilities of being less than those z-scores, and subtract the probabilities. So don't subtract the z-scores, subtract the probabilities. With example 4, what we're going to be doing is working backwards. In this example, you're going to be given the probability and you need to figure out what the x value is. So, the average life of a certain type of motor is 10 years with a standard deviation of 2. The manufacturer is willing to replace only 3% of the motors that fail. How long a guarantee should he offer? Assume that the lives of the motors follow a normal distribution. So if he wants to replace 3%, that means he wants 97% of the motors to be good. So we are trying to find this z-score, which will lead us to what that value of x will be. And that should be what the guarantee will be. So let's first let x equal the life of the motor, that is in years. And normally what we do is we take the value of x and we change it to a z-score, and then we take the z-score and look in the table. Then the number in the table gives us the probability. So what we're going to do is actually take this in the opposite way. We're going to find the probability and get the look at the table, and from the table figure out the z-score, and then from the z-score figure out the x value. So let's start off with the probability. The probability is 0.97. What you want to do, remember that these numbers are the probabilities, not these. So you're not looking for 0.97 here along the z-score. You're looking for the probability. Which probability is as close as possible to 0.97? So that looks like it's this one right here, 0.9699. So that's where you're starting with the probability in the table. From that, you figure out what the z-score is. So the ones and the tenths is 1.8, and the hundredths is 0.08. So the z-score is 1.88. So the z-score is 1.88. Now what we're going to do is figure out the x value using the z-score formula. So the z-score formula is x minus x bar over the standard deviation. So the z-score is 1.88. The value of x is what we're trying to solve for. The mean is 10 years. And the standard deviation is 2. Now we have to solve that. So first, multiply both sides by 2. So that will give us 3.76 equals x minus 10. And then now add 10 to both sides. So that would be 13.76 equals x. So therefore, the guarantee lifetime should be approximately 13.76 years, or you may want to round that to 14 years. And one thing you want to remember in the table is that the probabilities and the z-score, well, the probability wasn't exactly 0.977. So this should technically be an approximately equal to symbol. And every time you do these probability questions, it's really just approximately equal to, because that number here, even right there, has been rounded. So that's why you still need an approximately equal to, because even that 0.9082 has been rounded. It's not exactly 0.9082. So you really have to remember those approximately equal to symbols. And let me make them look a little bit prettier than that, since we went to all this work. Alright, so that's what you do when you're given the probability and you need to solve for x. So, what you want to remember is if you are trying to find the probability that your random variable is less than a number, you use the number in the table. If you are trying to find the probability that your random variable is greater than a number, it's 1, that should be minus the number in the table. And if you're trying to find the probability that your random variable is between two numbers, you have to take the probability of being less than the bigger number and subtract the probability of being less than the smaller number. And then to go backwards, as we said up here, you take your probability, you look in the table, you take from the table you get the z-score, and from the z-score you can use the z-score formula to solve for x. So what you're going to do is pause the video and do the you try questions, and then you can come back and check your answers. So press pause and then try them and come back and check your answers. Press pause now, please. Okay, welcome back to the video. So in this case, the variable is the wage. Because all questions refer to the same example, you only have to state the let statement once. The z-score is approximately 0.47. Because we're trying to find the probability of being less than the value, you just look at the table with a z-score of 0.47 and the probability is approximately 0.6808. For B, we were trying to find the probability of being more than, so the z-score was approximately negative 0.78, and the probability being less than negative 0.78 was 0.2177. Since we want the probability being more than that, you have to subtract that from 1. For question C, for each value, change it into a z-score. For each z-score, find the probability of being less than that number. And then to find the probability of being in between, you have to subtract the two probabilities. For question D, the probability we're interested in is 0.08. So that made your z-score approximately equal to 0.84. And then using the z-score formula, substituting in the z-score, the mean, and the standard deviation, multiply both sides by 1.6, add 1025 to both sides, and that means that the wage is approximately equal to 11.59, since it's money you round to 2 decimal places. So that's it. I changed a couple of things because I realized a couple of communication things that I missed. So on our examples here, this z-score, I should have said it was approximately 1.88 because it's not exactly, because we couldn't find exactly 0.97. And for these other examples, what I did is put in the therefore sentence. So the probability is approximately 0.7745. And again, a therefore sentence, and as well for the first question, putting in a therefore sentence. So that is normal distributions. What you want to remember is the 3 things that you have to do here, plus the example where you have to work backwards. So if there's anything you didn't understand, please make note of it and ask your teacher the next day. Thanks. Bye-bye. Z-score.